Okay, so take the class now. Previous class only I am going to repeat again. Polymers. These are the macromolecules having repeated units are called as the polymers. Macromolecules having a more molar mass, that is 10 to the power of 3, atomic mass into 10 to the power of 7 atomic mass units. Macromolecules having repeated units are called polymers. For example, butane A molecule which is going on repetition, we get a large molecule, that is a macromolecule, which was known as the polymer. This repeated unit joined by covalent bonds, joined by covalent bonds, which is known as monomer. That is, a monomers joined by these covalent bonds. These repeated units join together by this covalent bond to form a large molecule, which was called as the polymer. Macromolecules. All macromolecules are not polymers, but all polymers are macromolecules. For example, hemoglobin is a macromolecule but not polymer. The process which is used to make the polymer is known as the polymerization. Okay? Macromolecules having repeated units or joined by repeated units are called polymers. Generally, they have high molar mass, approximately 10 to the power of 3 atomic mass units to 10 to the power of 7 atomic mass unit. If representing with A atoms, that is the simplest single molecules which are joining. This A molecule is called as monomer, which is joined by the strong covalent bonds. All macromolecules are polymers. All polymers are macromolecules, but all macromolecules are not polymers. Come to the classification of these polymers. Polymers are classified based on the various things. One, based on number of different monomers. That is homopolymer. Second one, copolymer. If only one type of monomer is used in the formation of a polymer, that is known as the homopolymers. For example, a single molecule is going to be repeating number of times. That is, a simple or a single monomer is used in the formation of a polymer is called homopolymer. Example for these: polyethylene, polypropylene, rubber. If two or more monomers are used in the formation of a polymer, that is known as the copolymer. AG. So A is one type of monomer and B is the another type of monomer. Example for these: Gunaes, Gunae, nylon, 6,6. It is one of the classification which is based on the number of different monomers. Homopolymer and copolymer. Only one type of monomer is used is homopolymer. Two or more monomers are used. Copolymer. It is the first classification for the polymers. Based on source. One is natural polymer, semi-synthetic, and third one is the synthetic. Natural, semi-synthetic, and synthetic. These are obtained or present in nature. Example for these: Common example or well-known example, nothing but the rubber, silk, cellulose. These are some common examples for the natural polymers. They are present in the nature, that is in animals as well as in the plants. These are some of the chemical modification in the natural polymers are called as the semi-synthetic. Just some chemical modification will be take place in the natural polymers. They may be formed as the semi-synthetic. For example, cellulose acetate, nitrocellulose, simply called gel carbon, vulcanized rubber. Come to synthetic. These are man-made polymers. Example: nylon 6,6, PVC, polyethylene, etc. So based on source, there are three natural polymers: semi-synthetic and synthetic. Present in nature, natural polymers. Modification of some chemical modification in the natural polymers formed semi-synthetic, cellulose acetate, that is called rayon, nitrocellulose gun cotton, vulcanized rubber. Synthetic, these are man-made polymers. Examples: fiber come under nylon 6,6, plastic PVC, polyethylene, polypropylene, polystyrene. All these are come under the synthetic. That is a second class type of classification based on the source. Natural, semi-synthetic and the synthetic. Third one, based on polymerization mechanism. One is addition polymer. Second one is condensation polymer. It is formed by the addition mechanism. Example, we could be any of the, for example, PVC, Teflon, polyethylene come under the addition polymer. By addition mechanism, by condensation, that is addition and elimination reaction can be take place. Those polymers are come under the condensation. Example for these is nothing but the bakelite, nylon 6,6, terephthalate. These are come under the condensation polymers. But only addition polymer, addition elimination process can occur. Those polymers are come under the condensation polymer. Bakelite, nylon 6,6 and the terylene. It is third type of classification. Next, fourth, intermolecular forces. Thermosetting polymers. Elastomers, fibers, thermoplastic, and thermosetting polymers. Those thread-like substances having having intermolecular forces like hydrogen bond, come under the elastomers. Its strongest bonds like hydrogen bond and dipole-dipole interactions are present between the monomer units. They come under the fibers. Come to third one, thermoplastic polymers. These are the polymers. They have the intermolecular forces in between the plastic. Fourth one, thermosetting polymers. These are the polymers which are having strongest bond due to cross links. The cross links between the monomer chains, they are very hard and brittle. On heating, they become as hard because the cross links among of the monomer chains will be increases. These are the polymers cannot be remolded because they become very hard on heating. Example for these is nothing but the bakelite. These bakelite, that is thermosetting polymers, mainly used in the electrical goods. For example, electric switches, which are thin, they just melted, but cannot be remolded. So they doesn't have any much more damage. So this is the fourth level of classification based on the intermolecular forces, elastomers, fibers, thermoplastic, and the thermosetting. It is important. Elastomers are rubber-like solids like hydrogen bond and dipole direct. Example for these nylon, Orlon, PVC, polyethylene, polypropylene, polystyrene will all come under the thermoplastic polymer. Simply, most of the synthetic polymers will come under the thermoplastic polymers. Thermosetting polymers. These are the polymers which have much more cross links among of the linear chains. That is monomer units of linear chains. So on heating, they become as very hard and brittle. Example for the thermosetting polymers nothing but the bakelite. Any resins will come under the thermosetting polymers. Based on nature. One is linear polymer, branched polymer, cross-linked polymers. Come to linear polymers. Among of the polymers, these monomer units are arranged in a straight line with strong covalent bonds. They are closely packed. So they possess high density, melting point and boiling points. Come to second one, branched polymers. Among of the linear chains of monomer units, some of the branches are present with different lengths. Presence of the branches, they are not come closer to each other. So their value will be increasing between the one monomer chain to another monomer chain. So the value increases, density will be decreases. So these are the polymers which have low density, low melting point as well as the boiling points. And third one come to the cross-linked polymers. Among of the monomer chains, cross links are present between the monomer units. To break the bond, they require a high amount of energy. So these are very hard, brittle due to the presence of these cross links. It is the fifth classification based on the nature: linear, branched, cross-linked. Linear polymers can possess high melting point, boiling point, and density due to arranging staggered one over the other very closely. Presence of branches, they have much more distance between the one monomer chain to another monomer chain. So the density is very less as well as the melting point and the boiling points. Cross links. Some of the cross links present among of the monomer units to form as the three-dimensional network. These cross-linked polymers are also called as the network polymers. Another way they may be also indicated as one-dimensional polymers, two-dimensional polymers, and these are come under the three-dimensional polymers. So these all are the classification of polymers based on different monomers, homo and copolymer. Second one is source, natural, synthetic, and semi-synthetic. Third one, polymerization mechanism, addition and condensation polymer. Fourth one, intermolecular forces, elastomers, fibers, thermoplastic and thermosetting polymers. Nature, linear, branched and cross-linked polymers. Addition polymer or addition polymerization. These are also called as chain growth polymers. Like as organic reactions, this addition polymers can also have three stages, that is chain initiation, chain propagation, and the third one comes the chain termination. Like as addition reactions of organic, these are also involved in three stages: initiation, propagation, and termination. If the chain initiation is done by an ion, then it is called ionic polymerization. If it is done by a free radical, called as the free radical polymerization. Ion may be two types again: cation, ionic polymerization, and the free radical polymerization. In this addition polymerization, mainly they participate in monomers, which may containing of unsaturation. This carbon is known as the vinyl carbon. So these addition polymers can also known as the vinylic polymer. Chain growth as well as the vinylic polymer. If chain initiation by the periodical or maybe ion. For example, an initiator will react with this any unsaturated compound. So, initiation of the chain based on the periodical or an ion, it's two types, periodical as well as the ionic polymerization. In periodical polymerization, chain initiators are benzoyl peroxide, acetyl peroxides. For cation, HBr. For anionic polymerization, we use any amide compound. For example, lithium amide, alkyl lithium compounds. So these are the initiators for the cationic and anionic periodicals. Peroxides, mineral acids are Lewis acids are initiators for the cationic. Amides and alkyl lithium compounds. Cars. We may also use the RNGX in case R is a negative part, whereas in this negative part. So Grignard reagent is also in some reactions used as the anionic initiators. It is what about the addition polymers. That is the monomers join without eliminating any byproduct. Form a polymer is known as the addition polymer. It is called chain growth polymer or vinylic polymers. It contains three steps: chain initiation, propagation, and termination. Let's see some examples of addition polymerization. Ethylene, treating with the oxygen at 150 at 200 degrees centigrade and high pressure, it forms polyethylene. Titanium tetrachloride and trialkyl aluminium. It can also form an ethylene, which is known as the LDPE, and it is known as the HDP, high density polyethylene, low density polyethylene. It is known as the Ziegler-Natta catalyst. This catalyst was made a revolution in the polymer industry. He got Nobel Prize by evaluation of this catalyst. Later on, more number of polymers are synthesized by using of this catalyst with less amount. So polymer industry is boomed by using of the Ziegler-Natta catalyst. LDPE and HDPE. It will be same, but it depends on the condition. They may be asked any of these two conditions, which will be able to form LDPE and which will be able to form HDPE. Polypropylene, both can be used in the houseware items, like as toys, buckets, dustbin can be synthesized by the HDPE. Pipes, squeezer bottle can be synthesized by using of the LDPE. Maybe some they may ask the users also. Styrene can form and polymerization can form PVC. Cookware is coated by Teflon because it's a heat resistant substance. polyacrylate, which is commonly known as the Arla. Condensation polymerization. So these are the polymers which are formed by the eliminating simple molecule like H2O, NS3, and HCl, etc. A polymer which is formed by the addition and elimination simple molecule like H2O, NH3, CO2, HCl are come under the condensation polymerization. These are also called as step growth polymerization. In each step, length will be increased. So it is called as the step growth polymerization. Example, PET, polyethylene, terephthalate. It is also known as Becquerel or terylene. The monomers which are used in this nothing but the ethylene glycol, terephthalic acid. The hydrogen and OH is removed. Elimination of other molecule. It is come under the polyester compound. It's come under the polyester type of polymer. Polydecaron, terylene or polyethylene terephthalate, which is one of the example come under the condensation polymerization. A polymer which is formed by addition and elimination like single molecules. H2O, NH3, HCl, and CO2 are called condensation polymerization. They may be come under polyesters, polyamides are come under the condensation polymers. Condensation polymers are very strong because between these they may containing of strong intermolecular attraction forces. So condensation polymers are stronger comparing with the addition polymers. And sometimes they may give you some of the polymers and which is the identify which contains strongest intermolecular forces comparing with the elastomers like the rubbers, addition and condensation polymers. Condensations are stronger. They may containing of hydrogen bonds or dipole-dipole interactions. Compared to them, addition polymers are weak. Addition polymers are stronger than elastomers because elastomers contains very weakest forces which are van der Waals forces of attraction. Hexamethylene diamine HMDA plus 6 carbons of dicarboxylic acid is adipic acid. One of these hydrogen atoms and OH will be removed in the form of H2. 'Which is known as the nylon 6, 6. 6 carbons in hexamethylene diamine, 6 carbons in the adipic acid. These are example of nylon. Generally, why these are called nylon means a thread which was used in the New York and London. So it was named as the nylon. Having of two monomers, each will contain 6 carbon atoms, so it is called nylon 6, 6. Nylon 6. Capital atom. It is also called as the Paglangia. So make the hydrolysis. This bond is broken with pH. What it is now? 6 amino caproic acid. 6 amino caproic acid is the substance which is obtained by hydrolysis of capron. It is what we can call as nylon 6. It is nylon 6, 6. Now come to the question. Among of these two, it is come under the a polymer which is containing of two monomer units, so it is a copolymer. But whereas in this, it's containing of only one molecule, having of two different function groups. So it is a homopolymer. They may be asked in the exams point of view. Nylon 6,6 is a copolymer because it is contained two different monomer units. But when I come to the nylon 6, capital atom or carbonyl, which will be a homopolymer which contains only one monomer in it, having of two different function group, carboxylic acid and amine function. These two are come under the amine function group. So polyamides, polyesters come under the condensation, polymerization. They are very strong among of the polymers. Bakelite, most important, more number of times asked in the entrance level of examinations of its monomers. When phenol added with the formaldehyde at high pressure, it forms paraderivative. Ortho as well as the paraderivative. That means when phenol heating with the formaldehyde at high temperature and pressure, it will be converting into two products, ortho derivative as well as the paraderivative. It is called orthohydroxy methyl phenol, para-hydroxy methyl phenol. It is called hydroxymethylation on phenol compound. This gives the bakelite. If this orthohydroxy methyl phenol adding with the another mole of the hydrogen of the benzene and this OH group will be removed in the form of water to form a linear polymer. It is a linear polymer known as the novallac. Hydroxymethylation of phenol can give ortho as well as the para. If these two orthohydroxy methyl phenol compounds join together to form a linear polymer, it is called as the novallac. If we are using only one mole, we get as the novallac. The same phenol heating with the excess of formaldehyde can form bakelite. Using of 1 mole can form novelette. Using excess amount of the water, that's 1 is OH and H will be removed. Which is called as the bakelite. That is a cross linked polymer. Can form bakelite, sorry, novelite. Excess of formaldehyde and can form as the bakelite. Bakelite contains cross links, so it is very hardest substances. These are also called as the high molecular mass organic substances and also called as the resins. So bakelite is one type of resin substance. Rubber is obtained from the rubber trees, which are known as the Hevia brasilensis. By using from these plants, rubber can be obtained. When you cut these trees, stalks and leaves, we get a milky suspension, which is called as the. It is one type of emulsion. So this addition of the formic acid or acetic acid, it forms crude rubber, a milky suspension which is obtained from these rubber trees is known as the latex. Latex is one type of an emulsion. This latex will contain negative particles of rubber which can be coagulated by addition of formic acid or acetic acid to form a crude rubber. Two methyl 1,3 butadiene is the monomer present in the rubber. It is also called as the isoprene units. These isoprene units of a rubber joined by the 1,4 addition. These rubbers can be joined by the 1,4 addition. So when it is going to be added, double bond present in the 1 and 2, 3 and 4. When you make the bond formation, double bond come in between the 2, 3 carbon atoms. So these are the isoprene units can be joined by 1,4 addition to form as the rubber. This reaction is takes place in presence of a catalyst. Basically, sodium can also act as a catalyst in this isoprene units. When isoprenes join together to form as the natural rubber. So the monomer present in the rubber is nothing but the 2-methyl 1-3 butadiene or isoprene unit. Look at this molecule. When you look at this molecule, it is our isoprene unit. For this double bond, these two bonds are in one. So cis form of isoprene units are present in the natural rubber. More important, cis form of isoprene units are present in the natural rubber. This rubber will be vulcanized because the rubber has easily oxidized by the oxygen as well as the ozone, and it cannot absorb, do not absorb the water molecule. To improvise its physical properties, to improvise the physical properties of rubber, scientist who was called Goodyear proposed vulcanization. This rubber heating it is sulfur at 373 to 415 Kelvin temperature. It converted into vulcanized. This process is what we can call as the vulcanization. What happens when double bonds in the isoprene units? Among these two systems, these are cross-linked by cell fragments. On heating, more number of cross links will take place between these active methylene groups. So, as on heating, rubber became as the hard in nature. Because more number of cross links are formed between the isoprene units. That process is called as the vulcanization process. Vulcanized rubber is very hard substance. It is not easily oxidized by the oxygen as well as the ozone molecule. That is to improvise the physical properties, vulcanization process would be this can be used. It was proposed by the Goodyear. What is the process? Generally to form the cross links between the active methylene here chlorine, 2 chloro, 1 comma 3 butadiene used in the formation of neoprene rubber. If it is combined with styrene, it is known as monoids. If this 1 comma 3 butadiene vinyl cyanide, which is called as the Una. Yeah, natural rubber, synthetic rubbers. To accelerate that is to improve the vulcanization process, carbon and zinc oxides are used as accelerators to improve or to increase the vulcanization process. Carbon and zinc oxide are used as the accelerators for the vulcanization process. Polydispersity index. It is the ratio between the weight average molecular weight by number average molecular weight. The ratio between the weight average molecular weight by number average molecular weight is known as the polydispersity index. For natural polymers, they may equal to 1. For synthetic, greater than 1. How do we calculate the weight average molecular weight? Number average molecular weight. Weight of the polymers by number of molecules is known as the weight number average molecular weight. Basically, polymers are high molecular mass substances. So their molecular weight will be measured in average only. Number average molecular weight divided by number of molecules. Similarly, weight average molecular weight by molar mass of polymer. These two ratios can give the period. It is what the polymers briefly. So there is a chance to ask a question based on the molecular weight of the polymer. So the number as well as the weight average molecular weights. For example, come to this vinyl chloride now. It is a natural polymer or synthetic polymer. It is man-made, nothing but the synthetic polymer. It's an addition polymer or condensation polymer. It is addition polymers. Whether come to intermolecular forces. These are not elastomers, these are not fibers. These are thermoplastic polymers. It is synthetic polymer, addition polymer, and thermoplastic polymers. So they may ask giving a polymer to use any of these three, whether it is synthetic or addition or thermoplastic. And we come to the intermolecular forces. Condensation polymer is more than addition polymer, then come to rubber. So they give you some molecules, arrange the molecule in the increasing order of their intermolecular forces. So it is one, second, and third one. There is a possibility less importance to be asked as the molecular weight of the polymer. The most important thing, they give one polymer to you, and they may ask what was the monomer used in the formation of the polymer. And fourth one, they may ask if it's a homopolymer or copolymer. Find out whether it's a homo or copolymer. Depends on the monomer units. If it is only one homopolymer, more than one monomers are used, then it is come under the copolymer. Okay. Inform me tomorrow what topic you have to be discuss. Right?